Jai Hind all of you. Myself Dr. J.G. Yadav, Associate Professor in Electrical Department. Today we will discuss polar and rectangular form of AC quantities. Prior to this, we have discussed about phasors representation of AC quantities, and today we will discuss about polar and rectangular form of AC quantities. So, to discuss about polar and rectangular form of AC quantities, or we can say how we can mathematically represent an alternating quantity, that is mathematical representation of AC quantities. So, our AC quantities we can represent them in phasor forms, and also mathematically we can express them in two ways. First one is polar form or polar coordinate system of representation, and the second one is rectangular coordinate system of representation of AC quantities. As we know that any AC quantities can be expressed in general form. This is the general form of AC quantity, general or standard form of AC quantity. So, before performing any operation, any mathematical operation, that is addition, subtraction, multiplication or division, we have to write our given AC quantity in standard form. So, this is standard form where peak value is Im and phase angle is theta plus minus theta, and omega is the angular speed of rotation. Here in standard form peak value is given, so we can calculate RMS value of the AC quantities, which will be peak value divided by √2, and theta is naturally the phase angle. Now in polar form, we can say in polar form the same AC quantity can be represented as R angle plus minus theta. What is meaning of this? The same quantity is written here. By looking at this equation, we can find out what is the RMS value of this AC quantity, that is Im by √2. Hence, we can find this R, and by looking at this theta, we can say if it is plus, so angle R angle theta plus theta. If it is minus, then R angle minus theta. So, general polar form is like this. So, if in this mathematical equation is given, we can convert to this, and if this is given, we can convert in equation form, because in equation form we need Im. So, it will be √2 into R, and theta is given, so sin omega t plus minus theta is already given. So, we can convert from one form to other form. Similarly, in rectangular form, our AC quantity can be represented as this one, x plus minus jy, x plus minus jy. This is here j. So, where x is r cos theta and y is r sin theta, right? X is r cos theta and y is r sin theta. So, our AC quantity in rectangular form can be written as x plus minus jy. So, this is how, if this form is known, then we can find out what will be the value of x from this form. We can say r is known, so r cos theta, and y will be r sin theta. So, if rectangular polar form is given, we can find out rectangular form. Similarly, if x and y is given, then we can find out what will be the r. It will be, we will write here, if x and y are known, means x quantity is given in rectangular form, then to convert into polar form, r will be under root x square plus y square, and theta will be tan inverse y by x. So this will be value of theta. So x and y are known, then we can find out r and theta and represent the given quantity in our any form. We can see that from this quantity is given in this form, we can write in polar form, we can write in rectangular form. If quantity is given in this form, we can go to this form, we can go to this form. Similarly, if quantity is given in rectangular form, we can go to polar form, we can go to sinusoidal form or mathematical equation. And before doing any operation on the AC quantity, first convert that quantity into standard form or general form. It means if your quantity is given in cosine form, convert into it into equivalent sinusoidal form, and if sign is negative, make it positive. Make it positive. It means you have to write the AC quantity as small I is equal to Im sin omega t plus minus theta. This is the standard form. It should be positive, it should be sinusoidal. This is important. Before performing any operation, we write the AC quantity in standard form. This we will explain with the help of the example, numerical example also. Now, addition and subtraction of alternating quantity. How to perform addition and subtraction? So, to perform addition or subtraction, there are two methods. One is known as graphical method. So, in graphical method, suppose one quantity we take it as reference, and with respect to that quantity we will draw other, we will represent other quantity with respect to this reference in the phasor form or in the vector form. So, you have gone through vector addition, there are so many vectors, right. So, you can add them by taking one as a reference and drawing others from the end of the previous vector, so that their phase angles or angles are as given in the quantity. Suppose I have three quantities, I1 is equal to Im1 sin omega t, and I2 is equal to Im2 sin omega t plus phi 2, and I3 is equal to Im3 sin omega t plus phi 3. We have three AC quantities given. How to add them? How to add them? If they are given in sinusoidal form and this is in standard form, all three quantities are in standard form, no negative and no cosine, hence they are in standard form. So, we are taking first quantity as reference because its phase angle is 0, there is nothing plus minus, we can write plus minus 0. So, phase angle is 0. So, this is along x axis. Then we can see that for second AC quantity, phase angle is positive. Positive means above x axis. So, this is I2, second AC quantity, and this is x axis parallel to this is same x axis, and phase angle of the third quantity is phi 3. So, we will draw phi 3 here, and we will be drawing all these quantities to the scale. And if we are drawing these quantity to the scale, this line or vector will represent sum of this and this. So, this length is resultant, this is we can say IR will be, resultant will be I1 plus I2 plus I3, and these are phases where IR will be IMR sin of omega t plus phi r. means peak value of resultant is IMR and phase angle of our resultant current is phi r. So this is phase angle of our resultant, because this is resultant. So angle of this line from reference axis or x axis is phi r and length of this line is IMR. Hence the peak value it is IMR and phase angle is phi r. So we can represent our resultant like this. So this is our graphical method of addition. Then there is another method known as analytical method. In analytical method, we represent all the quantities in rectangular form, and for this represent each phasor to be added in sine function, and if any phasor is represented as cosine, then convert it to sine, and if sine of any function or any AC quantity is negative, then also convert it to positive. Means you have to write the AC quantity in standard form. Suppose we want to add two quantities which is I1 and I2, their equations are given here by analytical method. So what we will do, we will first see that whether they are in standard form or not. So we can see that this is in standard form, but this is not in standard form. So we will convert first this into standard form. What we have to do, we have to make this cosine as sine. Cos omega t plus 5, we can write sine pi by 2 plus omega t plus 5. So this is same, this equation is same as this one, but the form is now sinusoidal, that is standard form. So we can see that the phase angle of first one is 0, phase angle is 0, that is it is along reference axis. It is along reference axis, but phase angle of this I2, it is phase angle of I2 is this omega pi by 2 plus phi, pi by 2 plus phi, omega t, we can write this I2, rewrite again I m2 sine omega t plus pi by 2 plus phi. So we can say that the phase angle is this one, omega t plus the angle. So omega t plus pi by 2 plus phi. So hence phase angle of I2 is this one. Now to find the resultant of these two with the help of analytical method, what we will do, we draw them their phasors. And how to draw their phasors? Suppose I1 is this one, and we can see that its peak value is Im1 and phase angle is 0. So this quantity we can say that it is here along x-axis, peak value Im1, right? And we can draw the second quantity. The second quantity is this one. Phase, its peak value is Imt and phase angle is pi by 2 plus phi. Pi by 2 plus phi, first quantity phase angle was 0, that's why we drawn this quantity along x-axis. For the second, phase angle is phi, or we are taking here, we can take it. So here it is written theta, you consider it as phi. So this is phi, right? This is phi, you can say. So phase angle of second quantity, peak value is Im2. The length will be to the scale Im2 and phase angle will be pi by 2 plus phi. So pi by 2, this angle you know pi by 2, and this phi. So this angle becomes pi by 2 plus phi. So we can very easily see that this angle will be pi minus pi by 2 plus phi. It means this will be pi by 2 minus phi. So that's why we have shown here this angle, it is pi by 2 minus phi, because this whole is pi and minus of this, it becomes pi by 2 minus phi. Now how to calculate the resultant? To calculate the resultant, we find out the summation of x, the sum of all the components in the diagram along x axis. So summation x becomes the component of the first one along x axis, this is IM1. The component of first quantity along x axis is this one. And what will be the component of this quantity along x axis? You can very easily see that this is IM2 and this angle is pi by 2 minus phi. So component of this along this x axis, it will be IM2 cos pi by 2 minus phi. So we can say this is your and we will put negative sign because this is along negative x direction. This component of this along this, it is along the negative x axis direction. Hence we will put IM minus of IM2 cosine pi by 2 minus phi. So this is summation of x resultant phasors along x axis. Similarly, resultant phasor along y axis, it will be the component of this along y axis is 0 and component of this along y axis, you can say that this is y, this is IM2, its component along y axis, you can say this component or this component. So what will be this component? This component will be your sine of IM, component of this along y axis, it will be capital IM2 sine of pi by 2 minus phi, right. So this is y component of this IM2 along y axis. So we can write this summation x and y, it is written here. Component of all phasors along x axis, it is IM1, this is minus, not this one, minus, and cosine of pi by 2, and component of all phasors along y axis, it is IM2 sine of pi by 2 minus phi. So this is x component and this is y component. Now the resultant in rectangular form, it is summation x component plus minus j summation y component. So this you have got the resultant in rectangular form, that is summation x plus minus j summation y, and once you got the resultant in rectangular form, you can convert into polar form, you can write into equation, etc., etc., right. So this is how you can write the resultant of all the AC quantities or sum of all the AC quantities in rectangular form, and you can find out the resultant. So I think this slide is repeated. We have represented AC quantity in polar form, r plus minus angle phi, and rectangular form x plus minus jy, and this is relation between rectangular and polar form. So we have all done this. Now suppose how to perform multiplication and division of AC quantities. So to perform multiplication and division, suppose we have given two quantities P and Q. Suppose P is x1 plus j y1 and Q is x2 plus j y2. They are given in rectangular form, and suppose we want to multiply them. So multiplying in this present form, it is very difficult, but multiply or division when we convert them in polar form. Suppose P is converted in polar form and its equivalent is this. Q is converted into polar form and equivalent is this. Then multiplication and division of these two is very easy, because we know multiplication P into Q means this is P and this is Q. resultant will be R1 into R2, and angles here phi 1 and here phi 2, when they are in product they are added. So angle phi 1 plus phi 2, the product will be written as product of their magnitudes and sum of angle of P and Q, that is phi 1 plus phi 2. So this is how we calculate product of the two alternating quantity, or this is how we multiply two alternating quantity. Similarly, we can divide like this: P by Q, it is this by this, and here R1 by R2, we will take this as resultant magnitude, and angle phi 1 minus phi 2, this should be noted, the angle of resultant is phi 1 minus phi 2. While dividing, it is difference is taken, while adding sum is taken. So this is I think the same slide. Now the new thing is a numerical on this concept. The numerical question on the concept we have discussed. In this question, it is asked that two sinusoidal currents are given by I1 is equal to 10 sin omega t plus pi by 3, and I2 is equal to 15 sin omega t minus pi by 4. Calculate the phase difference between them in degrees. This is them. Calculate the phase difference between them in degrees. So how to calculate the phase difference between them? So we can represent these quantities in phasor diagram. Suppose this is your x-axis, this is your reference x-axis. Now consider the first one, I1. Its phase angle is plus pi by 3, means 60 degree. Suppose this is y-axis, so plus 60 will be somewhere here. So this is the direction of, you can say, I1. This is your pi by 3 or 60 degree, and phase angle of the second quantity is minus of pi by 4. Minus of pi by 4 means minus of 45 degree. So this is reference x-axis. Minus of 45 means direction of I2 is like this. Magnitude may be different, but direction is will be, this is minus 45, this is minus 45 degree, this is plus 60 degree, and this is minus 45 degree. So phase difference between these, very easily phase difference between these two, we can say phase difference between I1 and I2 will be equal to 60 plus 45 means 105 degree. So this is how we can calculate the phase difference between two sine wave. Now next question, calculate the write the polar form of the voltage given by this. This is the voltage equation. So we have to calculate the polar form and also obtain its rectangular form. So how to solve this question? Polar form means we have to write our voltage as R angle theta, where R, what is R? RMS value. We have explained earlier, R is RMS value of AC quantity. So RMS value means peak value divided root 2. So peak value means 100 divided root 2. So this is meaning of, we can say value of small r, so it will be 70.71 volt. And then what is theta? And theta, we know that general or standard form is small v is equal to Vm sin omega t plus minus theta or phi. So this Vm is the peak value and theta or phi is the phase angle. So by comparing these two equations, we can see that Vm is 100. That's why our RMS value Vm by root 2, 100 by root 2, this much, and theta here is, by comparing we can see that it is pi by 6, yani 30 degree. It means 30 degree. Okay. So we can write the polar form as the polar form of voltage, that is, we can write here same V as value of R, that is 70.71 and angle 30 degree. So this is in polar form, and also obtain its rectangular form. So rectangular form, how to write in rectangular form? How to write in rectangular form? What is rectangular form? We know rectangular form is x plus minus j y. And what is the value of x? X, it is r cos theta, and what is y? Y is r sin theta. How to relate them? Suppose our AC quantity, suppose this is x axis, right? This is your x axis, positive x axis. Suppose an AC quantity has RMS value r and phase angle theta. This is r and this angle is theta. Then its two component, this is x and this is y. This is y, right? So from this triangle, we can very easily see that x will be r cos theta and y will be r sin theta. R is RMS value of the AC quantity and theta is its phase angle. So if it is given in polar form, we can very easily calculate them in rectangular form, and from this diagram r is given and theta is given. It means you can say that this will be 70.71 cos 30 degree, and its value you can calculate, its value will be 61.23, and similarly y will be 70.7 sin 30 and its value will be 35.35. Hence our AC quantity, you can very easily say that our AC quantity is rectangular form. It is, you can write this as x means 61.23 plus minus j 35.35. This is our rectangular form. This is the, and we will y is since positive, hence this negative is not needed. It is 61.23 plus j 35.35 and unit will be volt. Since it is voltage, unit will be volt. So our AC quantity was given in standard form. We have calculated polar form and also calculated rectangular form. So this is how we can convert our AC quantities from one form to other form. Now there is another question, and this question it is said that a voltage is defined as minus Em cos of omega t. Express it in polar form. So how to solve this? We have to find out polar form. Right? We have to find the polar form of this. How to find out polar form? First we have to write the given equation in standard form, because we have already said that before doing any operation, please ensure that your given AC quantity is in standard form. and this is not in standard form. Why? There are two reasons. One is quantity is negative and also cosine. So there are two reasons why it is not in standard form, not in standard form. So first you have to convert this into standard form. Convert in standard form. How to convert this in standard form? Our AC quantity is E is equal to voltage. Suppose voltage है तो हम E की तरह लिख सकते हैं small e. Voltage small e is equal to minus Em cosine of omega t. What we will do? First we will make cosine into sine. So we can write this as minus of Em sine of omega t plus 90 plus pi by 2. Sin 90 plus theta cos theta, same formula. So we have converted this cosine into equivalent sign, Now we want to remove this negative also. So what we will do? We will make here positive, and this sin omega t plus pi by 2 means it becomes Em sin omega t plus 3 pi by 2. So this now is in standard form. This our expression is standard form. Why it is in standard form? It is both positive as well as sine form. So that's why it is in standard form, or you can say it is in standard form. It is positive as well as sinusoidal, or right. So what was the basic? We had to express this into polar form. Polar form means, what is meaning of polar form? Means polar form means r angle theta. What is meaning of r? R means RMS value, and RMS value, how to calculate RMS value? We know RMS value is nothing but peak value divided √2. And what is the theta here? Theta, by comparing, we can say this is theta is 3 pi by 2. Theta is 3 pi by 2. So in polar form we can write the quantity as Em by √2, angle 3 pi by 2. 3 pi by 2. What is meaning of 3 pi by 2? 3 pi by 2 means we can say Em by √2 angle 270 degree, or 270 is equivalent to 270 degree is equivalent to minus of 90 degree. Same we can write minus of 90 degree. How? Because suppose this is x-axis, right? So if we measure angle above positive x-axis, suppose, so this is plus 270 degree, this angle from here to here plus 270 degree, and if we measure the same angle from below the x-axis, so plus 270, so if we measure below x-axis, the same angle is minus of 90 degree. Oh sorry, something is mistake is, just a second, 270 is not, sorry, we will draw it again. Okay, this is suppose positive x-axis, and suppose we have to show plus 270, means we are measuring above x-axis. So 270 is 90 plus 90 180 plus 90 270. So this angle is plus 270 degree. And if we measure the same angle below the negative x-axis, so this is minus of 90 degree. So this is why I have written plus 270 degree is equivalent to minus of 90 degree. Means suppose a phasor is along this negative y axis. If any phasor is along negative y axis, then we can say that phase angle of this phasor is plus 270 degree, or the phase angle of this phasor is minus of 90 degree. है ना? In first case we were measuring the phase angle in positive direction, and in the second case we are measuring the same phase angle, the phase angle of the same phasor in negative direction or from below the x-axis. That's why we have taken as negative. So these are the same polar form. The three forms are equivalent, you can say. The three forms are equivalent, you can say. So this is how, if an AC quantity is in one form, we can convert it into any of the other form. Suppose it was given in rectangular form, we can write its equivalent polar form, we can write in standard sinusoidal form, or if it is given in sinusoidal, we can go into polar and rectangular. It means if our AC quantity is given any of the form, we can go in other two forms. There are three forms, we can go from any form to other two form. This is the meaning of this. So in this lecture, to sum up that, we have discussed what is polar form of the AC quantity, what is the rectangular form, and how we can go from one form to any form of the representation of alternating quantity. So this is all about for today. Thank you.